Hey everybody, this is Larry. This is me doing day 25 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. My apologies if this one's going to be very quick. It is 4:22 a.m. here in New York City because I spent way too much time doing that Leetcode contest virtually. Did pretty okay, but a little bit slow. Anyway, today is an easy problem, so that's good. I am going to take a good sleep after this. We have 145 binary tree post order traversal. Given the root of a binary tree, return the post order traversal of its node's values. Alrighty then. So then let's just crank it out, right? Post order. What does that mean? Post order means we do we traverse the node first, and then we process the value. So here we may do a post order node.left, post order node.right, and then now result we return append node. If node is none, just return, right? And that should be pretty much it, honestly. I know that I'm not describing much here, but and I'm wrong. Oh, it's the values, not the node. That's a very confusing error message, but yeah. Apparently I haven't done this problem before, so that's good. Always a good time for a new problem, new video. 1608 day streak. Yeah, I mean the idea is just, honestly, this is a easy problem. This is a tree problem. This is a post order traversal problem. All of this is pretty much ground level stuff. And what I mean by that is that everyone should know it for interviews and so forth. There's not much to talk about. This is almost like a definition test. So yeah, you have to know this. So I don't really know how much to talk about it. This should be pretty straightforward. Apparently, the follow-up is that recursive solution is trivial. Can you do it iteratively? I mean, yes. We can do it. But it's just calling a. So maybe that's what I can do to as an upsolve, even though it is a little bit late. But you just use an implicit stack instead of explicit stack. So then now we go yeah pen node, and then now I always forget how to write this. Yeah, well, length of stack is greater than 0, right? Then now we have top is equal to actually I'm really bad at this. Maybe it is a good practice, honestly. But yeah, it's just about writing it on top of the thing, right? Yeah, and then now current is equal to stack.pop, and then we want to do we want to do something like current.left, stack.append current.right, and then we process current as the all.append current.value, right? But of course that wouldn't do anything because you need to process these things first. So how do I do it? I actually don't remember. Because this will give you the wrong thing, right? You can't run it real quick. Oops. No, it's kind of awkward. Oh, I forgot to check the it's definitely a lot more awkward. Oops. That's right. But of course, it's not going to give you the right order because the processing here is whatever. Yeah, it's not after this, right? Not that. I thought it would be easy, to be honest. Let me give it a second of thought. I don't think I've. I mean, pre-order, I guess it makes sense. But okay. Oh. I mean, there are things you can do to kind of keep track of state, but I just feel like those things are kind of complicated, right? Or not complicated, but if, so the idea is just that you have to keep track of some states. The thing with having an explicit stack, which is an implicit stack, is that every time you do a recursion, you basically add to the stack, right? With some of like, but there's also a thing about where to go. So I think maybe this is a little bit awkward because maybe this is just the top of it, right? And then now I mean, yeah, it's a little bit awkward if I want to do it a little bit differently, right? Yeah, maybe it's fine. I don't know. Like you could just keep track of the state a little bit better if you really want to, but that is just like, right? So you do something like this. And then now you can check yeah, this and maybe like a counter or something, right? So you go to this. And counter is equal to 0. And we do this. Right? And if we well, we have to check that it's not equal to none. Or maybe the other thing first, actually. Right? Otherwise, I don't know why am I missing a parent? That's why I was trying. Otherwise, right? You add the current state 1. Yeah, it's a little bit awkward, but it'll work, right? Maybe you could even change this to whatever statement. Why am I missing like a lot of operation stuff? Anyway, yeah. And in this case, I guess we would pop anyway. Right. This maybe it's not. Why is this not easy? I don't know, honestly. Because if is none, then we just go to the same thing, right? Yeah, and then we just go, which goes to here. It's kind of interesting. I mean, what we want to do is just kind of keep track of what we've been doing. I think that's what I'm trying to do. But okay, so ref. Oh, am I? No, that's what I wanted to do. Keep track of the nodes. So there's gonna be 1. In state 1. No, we want oh, because we popped it, but then we should have. So after 1 iteration, we pop. Oh, we don't do this in either case. So I think we have to do this anyway. I think that's the thing. So okay, so maybe that will fix it. Okay, maybe not. because maybe the order of operations a little bit awkward. So what I want to do is increment it, the state, but I think my order of operation was a little bit weird because I'm not thinking about it. But yeah, I mean, definitely a little bit trickier, and it took me 9 minutes, so a little bit more trickier than I expected, honestly. The key thing is that when you look at your old code about stack version, it's just trying to think about what implicit states you're trying to think. And here, there are a couple of things, right? One is the implicit state is that the current node, and then the other implicit state when you go to the stack is that like where it is on the code that you're operating on, right? Like the line of code that you're operating on. In theory, sometimes they don't interact in a way that the ordering matters, and when the ordering doesn't matter, it becomes a lot easier because but here when the order does matter, you have to do something like this. And technically you don't pop in a pen doesn't really make sense. But it is maybe we could have, I'm so used to using tuple and enumerable what's it called? What is the word for unchangeable? Innumerable? No. What am I? Sorry, it's 4:30 a.m. right now, so I am not really not really thinking right. But yeah, so then here we want to do the top. Oh no, yeah, before we do, we right, something like that. It's maybe a little bit more accurate. Oh, it's a tuple still? Oh, because I hear, okay, fine. I forgot to change it in order places. I am way much barely awake. But yeah, this is maybe more natural in that we don't pop and then append, because that kind of looks a little bit wonky, but this is what we actually mean. And in C++, maybe you would like do a reference thing, so then you do a counter plus minus one, which is even cleaner. But yeah, same complexity, linear time, linear space, right? So yeah, I am going to pass out. So thanks for watching. Stay good, stay healthy to mental health. To good mental health. I'll see y'all later and take care. Bye bye.